All right, so FRQ 4 is just all about doing math. It's not about any kind of application. It's not about any interpretation. It's just doing the math, and it is the last FRQ, and it is a non-calculator one. And every number 4 has this information about give your answer in simplified form, just so there is no question that you need to make sure that if you can simplify it more, that you do that. All right, so we're going to do the yellow one first. And so it's going to involve logarithms. It could also involve exponential. It's definitely going to involve some trigonometric stuff. And so A part I is it tells us to rewrite G as a single logarithm of base 3 with no negative exponents. And your final answer should just be log base 3 of something. So I'm going to start off, and what can I do with these numbers that are in the front? There's a property. If there's a number in the front, you can move it somewhere else. Move it up to exponent. Good. So that's how we're going to start on our answer sheet. I'm going to keep calling it g of x. I don't know if that's important, but I'm trying to model the perfect answer. So we don't have it as a single logarithm yet. But you guys just did a logarithmic equation on the 3p, and I heard you all talking about it. So we want to bring this together as one logarithm. So what operation would you use? If it's separated by addition, bring together using... What does that mean? Multiplication.
That one where you like combine them.
Using multiplication. Okay. I guess you knew what you were talking about. Now, when we practiced these, when we did a lot of these, this typically had different variables and you would stop. But this is the same variable, and this is not simplified. So this is part of what they were talking about in the directions. So if I want to combine those x's, what would I do with the exponents? Yep. And that's it. Let's look at the next one. So then part 2 says to rewrite h as an expression in which secant of x appears once and no other trigonometric functions are involved. So we did a lot of these also. So h involves a bunch of multiplication and division. Do you guys remember what we typically did on those? Using the identities. Write them all using sines and cosines. I cannot promise you that's what you're going to need to do on your test. But if it's multiplication and division, typically, if you write everything using sine and cosine, then it works out. So how can I write tangent using sine and cosine? Good job. Sine of x over cosine of x. What about cosecant? 1 over sine of x. And then cosine is already cosine, so we're going to leave the denominator just like it looks. All right, what's going to happen to those sines of x's? They're going to cancel because you're multiplying, and there's one in the numerator, one in the denominator. And so h of x is going to be 1 over cosine of x over cosine of x. All right, so we haven't got to the final answer, which is going to only involve secant of x, but we're getting close. So I want to take 1 over cosine of x, which was the numerator, and I want to divide it by cosine of x. How do you divide by it? Multiply by the reciprocal, so we're going to multiply by 1 over cosine of x. So what's that going to give you? Where? Is that what you said? Oh, I just heard cosine of x squared. So the cosine of x squared is in the denominator, 1 over cosine squared of x. And then what does that equal? Secant squared of x. Very nice. All right, you might not have looked at those identities in a long time. It's probably something you should look back over. I think the ones we use on here are ones that you kind of just remember, but there are some other ones that might pop up. All right, let's look at part B. So we're given J and K on part B. And the first part, we are asked to find when J is equal to 4. So I'm going to take J, and I'm going to set it equal to 4. All right, so we have another logarithmic equation to worry about. I guess the other one was just an expression. All right, so we're going to kind of do the same thing. We're going to bring these logs together using multiplication because it's addition in between them. And on these log equations, there's two options. You can either drop off the logs or you can write in exponential form. But to be able to drop off the logs, you have to have logs on both sides. So this one's going to be exponential form. So you guys go ahead and take this logarithmic equation and write it in exponential form, please. All right, and this will be non-calculator, so you do need to know what 2 to the 4th is. What do y'all think? 16. Anytime you want to raise something to the 4th, what I do is I square it and then square that. So just square twice is raising it to the 4th. All right, now this one requires more room. You do have to stay inside the lines though. Apparently nothing outside the border will be graded. I think it's because it gets scanned into a computer and maybe that just doesn't even show up outside the line. So be really careful. All right, so this is a quadratic equation that we're going to end up solving at this point. So do you remember what we do to solve quadratic equations? A lot of them? Factor. We're going to get everything on one side and we're going to factor it. And hopefully with all the crazy difficult stuff we've done this year, factoring doesn't even seem like a challenge anymore. So we do end up getting 2 answers. So the quadratic equation has 2 answers. I'll let you guys get caught up. Sorry, some people are factoring on their own. So this quadratic equation has 2 answers. That doesn't mean the logarithmic equation has 2 answers. So when I take these and I plug them back in, I cannot get a negative argument. I can't get a 0 argument. So when I plug these numbers in for x, the argument has to be positive. So is -8 going to work? No, it's an extraneous solution, so you just mark it out. Is 2 going to work?
So if you get an X, a negative number, it's going to be like automatically.
Not automatically. Like if it had been like log of like 2 minus x, -8 would have been fine. Because you would do negative. So it just depends on the situation. You can't necessarily always mark out a negative. Just plug it back in and just check it. But if it's log base 2 of x and it's a negative you're plugging in, it's definitely not going to work. All right, and then the next one, we have k. We want to know when k is 7. So we'll just take k and set it equal to 7. And then solve this for x. So your first goal is just to get the sign of x by itself. So you guys take a second and do that. All right, and on this one, you are going to need to know that unit circle really, really well. So on several of these today, you're going to need to know it. But picture the unit circle in your head. Is there anywhere where it says the square root of 1/2? Square root of 1/2? Exactly? No. What does it say that you think is the square root of 1/2? Square root of 2/2. So we want to know when the sign of x is equal to either positive or negative square root of 2/2. Now I went over this. I'm doing this kind of fast because I want you guys to have some time. But don't go too fast because in the directions for this problem, it tells you that you're just finding the answers on this for the values of x on the interval from 0 to pi. So we're not going to give all the answers. So think about your unit circle. Zero to pi is here. And so we're looking for angles that the y coordinate is the square root of 2/2. Is it going to be negative square root of 2/2 at all for our region? No. So just the positive square root of 2/2. What angles are those?
Pi over 4.
Good job. Pi over 4 and sorry, my brain's working a little faster than my hand. And 3 pi over 4. That's it. I'll try to remember on this test, you are given no scratch paper, you're given no like reference sheet, you just do it all in your head. So I don't think when you're doing the free response that you have access to your test booklet for multiple choice. I think you turn that in. So you may have already drawn the unit circle, but it's going to be gone. So you'll have to start over. And you can draw it somewhere if you want to. Or you can just use parts of it that you know. What?
You always have your hand.
Yeah. Yeah, you always have your hand. You use your hand to do trigonometry?
No, I meant like drawing a unit circle on your hand.
Don't do that. No, please don't do that. All right, so let's look at the last part. So if you guys remember, each one of these questions is 6-point question. So the way this one works, that AI is 1, A2 is 1, B1, BI is 1, B2 is 1, C is going to be 2 points. Because it's usually the one that involves the most steps. So halfway through, you'll get a point, and then you'll get another point for the final answer. So anyway, we want to know where function m, we want to find all the outputs in the domain of m that yield, all the inputs, sorry, in the domain of m that yield the output of the arc cosine of that. So all they're telling you in kind of fancy words is to take m and set it equal to the inverse cosine of the square root of 3/2. Now, we definitely practiced these when we were taking the test on it. It's been a little while, so I'm not sure what you guys remember. But we want to start on the side that doesn't have an x. So we want to find the arc cosine or the inverse cosine of square root of 3/2, which is just going to be the angle that has that cosine. And for inverse cosine, we're just talking about quadrant 1 and quadrant 2. So what angle is it that has that cosine? Absolutely. All right, so that makes it a little easier to look at. So in the end, we're going to need to get to that x. So what would you guys do now? Yeah, divide by negative 2/3 or multiply by negative 3/2. All right, so I know that's going to be negative. I know the 3 and the 6 are going to reduce to a 2 in the denominator, so this should be negative pi over 4. All right, anybody remember what to do at this point? Yeah, change arcsine to sine. So if we have the arcsine of all this stuff equals negative pi over 4, that means that the sine of negative pi over 4 equals all that stuff. Okay, this is one I swear you have to remember every single thing we learned all year to get this question right. So first, we need to remember about sine. If sine's even or odd, you don't have to remember the words. But for sine, this negative, does it just disappear or does it come out in the front? It comes out in the front. Sine is odd, so that negative just comes out in the front. And then we can just worry about pi over 4. If it had been cosine, which is an even function, then that negative just dissolves, it just disappears. All right, so what is the sine of pi over 4? All right, and then finally, we can solve this for x by dividing by 5 square root of 2, which is the same as multiplying by the reciprocal. So the square roots of 2 cancel. I made a real mess of this work, but that's going to be negative 1/10 in the end. So I feel like, I can't remember. I feel like getting to this point gets you a point, and then getting to this point gets you the other one. All right, so let's do the green one. It's very similar. This one does have an exponential thrown in there, and then instead of C being like that one, it's a different type of C. Still same rules about simplifying everything perfectly. All right, so it looks like the first one is the exact same rule. So we'll take that 1/2 and we'll make it an exponent. Take that 3, make it an exponent. You guys go ahead and do that. All right, and then these are separated by subtraction, so we're going to bring them together using what? Division. All right, this is not completely simplified because those exponents we can still do something with. What do you do with exponents when you're dividing? Subtract. And so we're going to need to subtract 3 minus 1/2. Now, it says your exponent can't be negative. It doesn't say it can't be a fraction. It doesn't say it can't be a decimal. So do you guys want to do fractions or decimals here? I don't hear what you're saying. Anybody have a preference between fractions? Fractions, thank you. So 3, how many halves is 3? 6 halves. 6 halves minus 1/2 is going to be 5 halves. Okay, so it's going to be x to the 5 halves. Is it going to be on the numerator or is it going to be in the denominator? Why? You're right. Yes. So the denominator exponent is larger, so when you do that subtraction, that's where my leftover x's are going to be. And I feel like we could go further with this, but I feel like we have all the rules that they've set forth. This is an acceptable answer. We also could have done 1 over x to the 2.5 if you prefer decimals. All right, let's look at the second one. So on the second one, I would really appreciate it if you quit talking. All right, So on the second one, we're going to take that h and we are going to rewrite it so it's only cosine of x. And there's no other trig functions involved. It only appears once. This one, we have to use a property we haven't used today. Do you guys know what sine of 2x is also equal to? 2 sine of x cosine of x. Good job. That's the hardest part of this problem, is just remembering that property. After that, what happens to those signs? They cancel, and what does it leave you with? And that is only cosine. It only appears once, and so we're done. All right, so let's look at B. On B, we're going to take J, and we're going to set it equal to the square root of 10. This one's kind of tough. So eventually, we are going to want to solve this for x. What would you guys do with this square root of 10 if you were doing this on your own? It won't cancel. I would add it, yeah. So we would add it to the other side. And then what would you do here with these exponents? You would add them. Is the 10 going to change? And when you add the square root of 10 and another square root of 10, do you know what you get? That's what you would get if you multiplied. You'd get 2 square roots of 10. Okay. Now there's only one way to get this down. Do you guys know that way? Log. So we're going to write this in logarithmic form. You technically don't have to write the base of 10, but it's going to be log base 10 of 2 square root of 10 equals the exponent of x plus 3. And this is where this problem gets really difficult to get your point. Because they tell us, like, you can't leave an unreduced logarithm. If this had been the square root of 7 or something that didn't involve a 10, it would be really easy. We would just subtract 3 and we would be done, but it doesn't. So what we're going to need to do is use the properties of expansion. So these are together with multiplication, so we're going to use addition to separate them. And you also need to know what exponent means square root. Do you know what exponent means? 1/2. You do not have to write that down. That was just like a side note. Okay, so log base 10 of 2, there's nothing you can do. It's just log base 10 of 2. But what about log base 10 of 10 to the 1/2? What is that? That is just 1/2. Okay. So now we can subtract that 3. Now we already subtracted 3 and 1/2 just a second ago, and we got 5/2. So you can just use that again, or you can do 2.5, whatever you want to do. That's the answer. That's a tough point to get. It's a whole lot of work for 1 point. All right, and then B part 2 is similar, so slightly easier than C on the last question. And so we want to know when K is equal to 5 pi over 3. So we'll just start off and set it equal to it. And I don't really really know why, except maybe he just wanted to make sure you simplified it. But when I see the square root of 4, we just need to make that 2. Okay, so look at C on the last question and see if you can solve this from here. So this is like kind of like starting on the second step. So what is the cosine of 5 pi over 6? Good. Negative square root of 3 over 2. Okay. And then at this point, you can either divide by negative 2 or multiply by negative 1/2. And then what do? You just get x. You guys know. How do you get rid of a square root? Maybe you don't know. You're going to square. And so that's going to be 3/16 is x. Okay, one more, and it's also kind of tough. It is a 2-point question, so you can get half of the credit. Okay, so in the last one, we're going to take m, and we're basically going to set it equal to 2. So it's some weird directions that ask you pretty much to do the same thing you've been doing on the rest of this part. And we did some that would have like maybe it would have sine and cosine both in it, but we would just like factor out a common factor and we would be able to make it work. This does not have a common factor. And so the way this is written right now, we straight can't solve it. So we need to make this cosine, we need to rewrite it as sine. Any ideas on how to do that? Yes. So he is saying take this one that we all know and basically solve it for cosine squared. So that means I can take 1 minus sine squared of x and put it where cosine squared of x is. All right, then I'm going to combine all my like terms. Whoops, it shouldn't equal 0, my bad. It should equal 2. And then I'm going to move the 2 over all in one step. All right. And then this gives us like a trigonometric quadratic that we're going to factor. It's going to be different than what we're used to. So what we put here and here needs to give you 2 sine squared of x. So that's going to be 2 sine and sine of x. And then we're going to need to get -1. So this is going to be plus minus. And then the only way to get 1 is 1 and 1. And then you just need to double check your signs for a second. So in the middle, we want to get minus sign. So it's -2 plus 1 gives you your -1 sign. All right. So I feel like I need to look at it closer. Getting to that gets you a point, but I could be wrong. Actually, I am wrong. Still haven't got a point yet. All right. Then we're going to set each one of those equal to 0. Okay, so on the one we just did, on the yellow B part 2, we did an equation, and we were doing an interval between 0 and pi. Did they give us an interval at all on this one? No. So what do we have to do with our answers? Yes. So we are going to find the answers from the unit circle, which are going to be 7 pi over 6. 11 pi over 6. And then for sine is 1, we want the coordinate where the y is 1. What's that going to be? Pi over 2. And then you need to tell, we didn't do this before, and we should have, that was my fault. We need to tell the people that k is an integer. Because if k was something like 1/2, this wouldn't be true. But as long as k is like 1 or 2 or 3 or 4, negative those numbers, then that's good. So I remember now what it is. You get 1 point for getting these, and then you get 1 point for getting these. So if you forget that, you still get a lot of points. All right.